We're not sure that we will be able to have windows inside of these hypersonic airplanes. It's quite challenging to have windows, but as a replacement, there's a lot of developments right now in these artificial windows, LED screens, and we would make sure to make it a good experience.
Hey, SpaceWatchers! What you just heard is not science fiction. That is the future. And this is Space Café Radio, your channel about trends, great people and awesome conferences. I'm Thorsten, publisher of SpaceWatch.Global. During the IAC 2022, the International Astronautical Congress in Paris, I talked with Martina Löfqvist, Senior Business Development Manager at Destinus, about their vision of long-haul transport and what they do at the Congress. Enjoy our conversation. Martina, what is your space story?
Yes, thank you. So I got into the space industry after living in California, where I met a lot of interesting people that were working for SpaceX at the time and Virgin Orbit. And before that, I was working in the finance industry with a background in computer science and business. And I wasn't aware that there was a possibility to get into this industry. So my story started in the UK. I was working for a company called Astro Agency. And after that, I moved over to Momentus in the US, where I was working with the founder of the company, Mikhail Kokoric. And sometime after that, when he moved away and started a new company, I moved along with him as well. And the reason for that was because he came up with this really exciting company and the business idea and vision called Destinus. And the vision of the company is to reduce transportation everywhere on Earth so that you can get instantly to any place on the globe. And by doing so, we are developing airplanes that are powered by hydrogen that will be able to fly at hypersonic speeds, so over 5 times the speed of sound.
Let's break it into chops. That sounds really like science fiction. So after you're meeting up with and hanging out with Elon in California, you got this vision of space. Is that what you're saying? And you're infiltrated by the space geeks. But Destinus sounds really a lot about science fiction. Transport point to point on Earth. I think we solved it today by plane. What is different? What is it? Maybe you can start from the beginning.
What we see when looking at the aviation industry, there's not much that has changed over the past years. We're still using jet engines that are flying below the speed of sound. We tried with Concorde to reach supersonic speed, and it was commercial for some years. But then due to various challenges, they stopped the program, and we don't have anything today on the civil side that is flying above the speed of sound. So we really believe that there's a market for this, and we can see that there are a lot of companies that are starting to develop airplanes that can fly at supersonic or even hypersonic speed. The other problem is that the aviation industry is extremely dirty, so there's a lot of carbon emissions. It contributes to 2.5% of the carbon emissions worldwide. It's a quite significant number, and we're dependent on transportation, so it's something that we have to change. It's not something that we can remove. That's why a lot of companies today are starting to look into alternative aviation fuels. So there's the sustainable aviation fuels called SAF that a lot of companies are looking into. We decided to look into hydrogen instead because if you want to match the high speed together with sustainability, you have to look at fuels that are highly efficient. And hydrogen is extremely efficient. So when you go above, say, Mach 3 or so, hydrogen becomes more efficient than using kerosene as a fuel. And that's why we're using that for propelling our rocket engines. Another area is also that many companies are looking into electric aviation, and it's great for regional flights. But if you want to really tackle these ultra-long range flights, which means flights that go from one continent to another, that takes above 16 hours today, then you have to come up with a solution that works for that. And electric is not the solution due to the large size of the batteries. That's why we believe that hydrogen is probably going to be the best solution in terms of the fuel.
You're aiming really for human transportation?
Yeah, so the ultimate goal is to be able to transport passengers all over the world, as well as cargo. And we see cargo being more as an entry point. So it is civil aviation that we want to change across the world. And we believe that these airplanes will be flying between some global hubs. As I mentioned, they're not going to make sense to have at short distances. So we will probably have 100 hubs or so globally spread out that these airplanes can fly between. Another huge benefit of taking this and why it's so important for people as well is that you can change the way we go to places and how we visit various destinations, whether it's for holidays or whether it's for work, you want to make sure that you spend time at the destination. You don't want to spend 15 hours in an airplane. So these ultra long haul flights today, which is above 16 hours, they will be flown in about 3 to 4 hours instead. So we're significantly reducing the time so you can spend more time at the destination. And that's where the name Destinus is coming from, because the destination is the ultimate goal.
If I recall Elon's views on point-to-point transportation on Earth, he proposed a few years back to fly with a Starship, a vehicle, go to space, coming back, re-entry, and going point-to-point within an hour all over the world. Is it a similar concept you have, or is it then staying in the aviation institute?
Our concept is quite different in terms of the way we take off. We have a horizontal takeoff rather than a vertical, which means that we're not dependent on spaceports where the rockets have to launch from. We can instead use any conventional airport as long as the runway is long enough, any big international airport, which means that the infrastructure is already there. What we need to add to that is then the hydrogen infrastructure, the hydrogen refueling of these airplanes. Another key difference is that we will be able to, as I mentioned, take off and land from the standard airport, but we will also be able to make the flights quite comfortable in terms of how we accelerate them, since vertical launch might mean that you will be thrown around differently and you might have to have extra seatbelts on, but we will actually try to make it as comfortable as possible for the passengers. So it's replacing...
What does it mean in terms of G-force?
Yeah, so we don't have an exact number for the G-forces, but we do have as a requirement to stay below 1 G-force. And that's in order to be able to have a good service. It's during the acceleration phase when we take off and switch from one engine to another, from an air-breathing engine to a rocket engine. That's when the acceleration might be more noticeable. But then when we're at cruise, and we plan to cruise at above 30 kilometers of altitude, that's when it will be less noticeable. And you can take off the seatbelt and you can do your work and you can get nice dining service as well, which I'm not sure if Starship is planning on doing that.
So 30 kilometers means that you see the Earth and its curve and you see the black sky, the black space.
Yes, exactly. However, we're not sure that we will be able to have windows inside of these hypersonic airplanes. It's quite challenging to have windows because of the high temperatures, and we need to make sure that the surface of the airplane is cooled. So we're planning on using liquid hydrogen to cool the leading edges of the vehicle. It might be difficult to have windows, but as a replacement, there's a lot of developments right now in these artificial windows, LED screens, and we would make sure to make it a good experience together with the airline that we would plan to work with. So yeah, the 30-kilometer altitude is quite high. We might even go higher than that. We have looked into getting perhaps all the way up to 70 kilometers. So it's to be determined depending on the speed we reach. The most efficient speed for Mach 5 is around 32 kilometers. And the most efficient for Mach 6 is around up to 40 kilometers. So it really depends on the speed that we are able to achieve with our engines. And since they're currently underway and in the design phase and eventually going into the testing phase starting next year with the air-breathing engines, and then in 2 years from now with the larger engines, we will get a lot of insight from those performances.
So passenger transport is driven by the regulation and the standards and the certification is a very long process, I assume. If I'm correctly imagining it, I would say 10, 15 years from now, maybe. But I'm quite sure you do something today for establishing the kind of aircraft.
So we already built and tested 2 flying prototypes. Although at subsonic speeds, they gave us a lot of insight on the regulatory side because we had to go through an approval process. We are in good connections with the agencies in Switzerland and in Germany in particular for flight approvals. And then we're working on licensing now in Spain and France as well for the supersonic flight that we plan to have flying by the end of next year. And that will be a different kind of certificate because it's a larger vehicle and it's flying above the speed of sound. And we plan to introduce hydrogen as fuel inside of it as well. So we're going for
Are these piloted or are these remote steered? How does it work?
The prototypes that we're developing are not piloted. We're developing an autopilot system instead. Right now they're remotely piloted, but we're transitioning to this autopilot system so that they can operate autonomously and that we have a safety pilot on the ground. The reason for it is because if you put a person inside, it's going to take a lot longer to get the approvals to fly. Eventually, we will be introducing pilots and humans, but we want to get the technology developed first. So the engines to be tested on board these vehicles and certified. because you need to have engine certification before you can put humans into the vehicles, and to test out the aerodynamic shape as well as the autopilot system itself and the aerodynamics of the vehicle. So we can do all this without having humans on board. And then eventually, in some years from now, we'll introduce the first pilots and go through extensive certification for that. But we are already working to some extent with IAC and Eurocontrol and having discussions with them from time to time to make sure that we are kept in their minds for the new regulations that will be put in place for supersonic and hypersonic flight. And we also talk to some of our competitors who are facing the same challenges so that we can try to go about this together. But at the moment, we're not putting a lot of effort on the regulations because that can slow us down significantly. So we're doing it slowly, but it's in the back of our mind, and we will push for it more once it becomes more relevant.
You have a very esteemed board of people that helping you, that supporting the idea, that are obviously touched by the vision. Can you talk about them a bit?
We have a few new board members from the past year and advisors who are helping us out. For example, the astronaut Pedro Duque is on the board, so he is extremely valuable when it comes to the space side and the connections that we can get there through the agencies, specifically in Spain, since he's based in Madrid, where we also have an office. And then we have a pretty well-known entrepreneur, Conny Borsch, on the board as well. He is helping us a lot with introductions to investors and other useful introductions that we may need. He was in the company from the start, essentially. So Mikael and Conny know each other quite well. And then we also have on the advisory board some interesting people who have been in the space or aviation or hydrogen industries for some time, who are providing the advice that we need to be able to move forward as quickly as possible.
Now, we're here at the IAC. What is the International Astronautical Federation? What is the connection to space?
So our company is really a mix between aviation and space. We're developing technologies that are useful for both of these, and we are also using technologies that are both really. They're two very important industries for us. On the space side, we just had a presentation about our air-breathing rocket engine that will be fueled by hydrogen. So this one is already in development, in the design, and we're starting to move into the manufacturing phase and developing the first prototype for next year. And why this is important is because this can be used, for example, for first-stage launchers, horizontal first-stage launchers. And the other engine, the rocket engine that we're looking into, can, of course, then also be used for vertical launches. So there's various applications of the technologies. And as I mentioned earlier, we're developing this active cooling system for the leading edges of the vehicle. This one, which we've sent a patent for, can be used for re-entry vehicles. There's a lot of synergies between the two in terms of the structures of the vehicle, the materials that will be used. There's a lot of crossover. So we're talking to a lot of interesting people here at the IAC to see what kind of support we can get and where we might be able to do some technology transfer with companies who are in the space industry.
So it's an exchange on the technology, on the component level then. It's not that your next destination is then the moon with your rocket or with your plane.
So there are different possibilities with using our hypersonic vehicles as a platform. And we have been evaluating different types of products. And there might be some products such as horizontal first stage to orbit that could be relevant for the space industry. But it's not something we're pushing for at the moment. We're keeping it open and evaluating what are the different products that we can deliver in the shorter term before we get to the passenger flight.
Martina, thank you very much. It was great to talk to you, and I wish you good luck for the next steps.
Thank you. Appreciate it.
And if you want to stay on the pulse of the space industry, please visit our website at www.SpaceWatch.Global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Thorsten Greening, publisher at SpaceWatch.Global, your independent perspective on space.